Hello. I think I will be live after some time. So yes. So today we will revise set theory of class 11th. So this is again, I am saying this is only for revision. This is not, I am not doing anything from scratch here. So yeah. So all the basic things about what is set and what are the types of set, what are the operations on the set, what is the cardinality. I won't discuss all of them, but yeah, I will let us discuss about cardinality also, even if we don't want. So cardinality of any set is represented like this, and if that set has a total of n elements, then 2 to the power n is the cardinality. That means there can be 2 to the power n subsets of these sets. This is because, let's say there is a set A in which there is element 1 comma element 2 comma element 3 comma element 4 dot element n. Then each of the elements have two choices, either to join subset or not join subset, right? Let me check if I am live or not right now. Just 1 minute. Yes, I am live. So each of them have two choices, that if they want to join or they don't want to join the subset. So there are two choices for n elements. Therefore, the total number of cases, like total number of ways in which a subset can be formed, is 2 to the power n, right? So yeah, this is a very fundamental thing, and we need to know these because we will use this after some time. So let us go and solve a question based on cardinality. And it was a question. The question was, let me see the question first. Difference of cardinality of two sets. Difference of cardinality 2 to the power. Sorry, this is the number of elements. Cardinality of a set is number of elements, and what I was telling you here, this is not cardinality. N of A is n. What I was telling you here was number of subsets. So cardinality and number of subsets are different. 1 second. So yes, it was number of subsets. Cardinality of a set is just n, the number of elements in the set. So yeah, after all of this, let us now move towards question. The difference between the number of subsets of two sets is 56q, where is q is the smaller of two prime roots of x squared. Let me write the important thing: x squared minus 15x plus p. So the thing is, number of subsets, there are two sets, set A and set B. The number of subsets will be 2 to the power n of A. Let's say n of A is small a, and 2 to the power 2 to the power B is the number of subsets of B. So yeah, it is saying that the difference of the subsets is given as 56q. So subtracting both, it is given as 56q. And then it is saying that q is the smaller of the two prime roots of this equation. So q is the smaller of two prime roots of this equation. So two prime roots of this equation, this is p, this is variable. So in two ways we can solve it. Let us, so 15, alpha plus beta, if two roots are alpha and beta, then alpha plus beta is given by minus b by a. This is called Vieta relation in quadratic equation. So alpha plus beta is equal to negative of b by a. So negative of b by a will be here 15. So alpha plus beta is equal to 15. So sum of two numbers is 15 only when one of the number is even and another number is odd. So odd can be only obtained by adding one even number with odd number, right? So yeah, so we can write only it this way, because if we will add odd plus odd, it will come out to be even, and if we will add even plus even, even that will be come out even that will be even only. So getting an odd number as a sum is only possible if we will add an even number with the odd number. So by that way we know that only the only even prime number is 2. So here q is 2 because there is no smaller prime number than 2, and it is given that q is the smaller of the two prime roots of this particular equation. So if we will say alpha is equal to 2, then beta will be equal to simply 13. So yeah, otherwise if you don't want to do it this way, you can also do that by hit and trial method. There is no problem, but yes, you can do it this way also. Now after all of this, we know what is the value of q, so let us now move forward and so moving forward, let us say that b is smaller than a, then 2 to the power a minus 2 to the power b is equal to 56 into 2. Yes, so 2 to the power b, let's say we have taken common, then it will come out to be 2 to the power a minus b minus 1. So 2 to the power something minus 1 is the odd number. So here let us now factorize this to get an odd number. So it will come out to be 7 into 8 into 2. So the only odd number here will be 7, no other odd number can be formed. So 2 to the power b is equal to 8 into 2, that is 2 to the power 4. So b is equal to 4, we got here. A is equal to what? A is equal to 2 to the power a minus 4 is and whole minus 1 is equal to 7. So 2 to the power a minus 4 is equal to 8. So a minus 4 is equal to 3, a is equal to 7. So a came out to be 7, and now the value of p, what will be the value of p? We also have to find out the value of p. So p was nothing but the product of both the roots of the initial equation, so that will come out to be 2 into 13, which will be 26. Yes, so this was one of the question, and then second question given to me there was this is a very good question. A question, but this is a good question, not very good question, but yeah, this is a good question. So there was given a set A set A such that x belongs to set A such that x is equal to a comma b, ordered pair a comma b, and a square plus b square is equal to 625. Now and a and b belongs to integer, right? So a square plus b square, a square plus b square is equal to 625. There will be infinite number of real solutions for these two. Put any value for a, you will get a value for b. but integer values are very little, so we will have to manually find out how many of them are this. So firstly it will be 625 is simply 25 ka squared, so 0 and 25 I can right now see. Then which one to check? So every number ending with 2 will give a square with a square ending with 4. 3, 9, 4, 6, 5, 5, 6, 6, 7, 9, 8, 4, and then 9 will give 1, 9 will give 1, and 10 will give 0, and 1 will give 1 obviously. So how can we add two numbers to get 5 at the end? So 1 can be added with 4 and 1 can be added with 4. No other number added to 1 can give us 5. So we can check 1, 11 and 21 with, we can check them with 2, 12, 22, right? And since 8 also gives 64, we can check it with 8 and 18. And similarly, since 9 also give 1 at the end, we can also check 9 and then 19. We can check this way, and after checking we will find out that 24, so this way we can find out like 4 will be added to 1, and then 9 will be added to 6, so we will check with 4 ending things and 6 ending things, and similarly we can check. So we will get that there are two natural pairs, 24, 7, so AIR 247, JE for a reason. Now 24 and 7, this will be one of the cases, right? And another case will be, let me check right now here, I don't exactly remember, I think it was 14 square 196, and let us subtract 625 from it, so it will come out to be 9. 11 minus 9, it will come out to be 2, and it will come out to be 4, and 429 I think is the square of 23 into 23. No, I don't think so, it is square of anything. Let me just check again. Equal to 9, 3 2s are 6, 23, 46, it is 529. Have I made a mistake here or something? This will come out to 5. Yes, this is, there is no problem in this one. This 5 minus 6, 9, 1 carry, 11 minus 9, 2, there was 1 carry, so 5 minus 1 is 4. Yeah, then by small margin we missed this out. So these, and then comes out to be, I guess it was 13, so 169, 625, so 15 minus 9 will come out to be 6, 11 minus 6 will come out to be 5, and 5 minus 1 will come out to be 4, 456. I think we are getting somewhere. 421, 22, 23. No, these are not getting us any, these things are not getting anywhere. So let us check with 17, it gives 289, and 625, 15 minus 9 is 6, 11 minus 8 is 3, 5 minus 2 is 3, 336. Oh, a beautiful number, but not a square we need. Let us check it with 625. Let us bring more numbers to the table. 225, 400. Okay, okay, 225, and this was a bit easier. So yes, another case is let me write it with brown color, 20 and 15. So this is one case in itself, but since here a comma b belongs to integer, we can we cannot be happy by getting only these two sets of values. So we will check how many integer pairs we can make out of it. So since it is 25 and 7, and one case was obviously 0 and 25, so yeah, so 24 and 7, we can write plus 24 minus 7 minus 24 plus 7 plus 24 plus 7 minus 24 minus 7, right? These are the four cases, and into two cases, because these were ordered pairs, so 7 comma 24 ka there will come 4 case also, so it will be 8 cases total. So this will yield us 8 cases, this will yield us 8 cases, but since 0 does not have any positive or negative thing, this will give us only 4 cases. So that will be plus 25 minus 25, and opposite side plus 25 minus 25. So this will give us 4 cases. So 8 plus 4, 20 cases will be there in total. So yeah, this was interesting question. And now let us talk about the operations on set. So operations on set is a very basic thing. So there are different terminologies used in mathematics. So first is idempotent law. So idempotent law is that set A union set A will give set A only, like 0 plus 0 is equal to 0. Here also set A union A will give 0 only, it will give A only, then A intersection A will give A only. So these two are idempotent. Then becomes identity law. So like for addition in numbers, we have 0 as additive identity, because if we will add any number with 0, it will not lose its identity and it will be same. And likewise for multiplication, 1 is the multiplicative identity. Here for sets, for union, identity set is 5, because A plus 5 or A union 5 is A only. Then comes multiplicative, then comes intersection. So for intersection, universal set in any case is intersection identity. So these two are identities. And then comes commutative law, associative law, and distributive laws. So there are 3 kind of laws. So I'm just writing all of them one by one. So union of sets A union B is equal to B union A. These all are commutative law. Then comes A intersection B is equal to B intersection A. Then comes A plus B is equal to B plus A. And there is one thing, A minus B is not equal to B minus A. So subtraction of sets does not follow commutative law. Does not follow. So yeah, it does not follow. And then comes associative law. So associative law results are like A union B union C is equal to A union B union C, because this is nothing but we are taking everything in A, B and C. So if we will take first everything in A, first everything common, everything in, not common, everything in B and C, and then we will add everything in A, it will be same as if we will take all of them together. So yeah, and this way, and then comes A intersection B intersection C is equal to A intersection B intersection C. So at the end of the day, what result we are getting? We are getting whatever is common between A, B and C, and here also we are getting same thing, whatever is common between A, B and C. And then comes union and intersection together. A union B intersection C is not equal to A union B intersection C, because here B and C, whatever is common between B and C is being taken along with everything in A, but here everything common between A and B is being taken, everything in A and B is being taken common with C. So some part of A will come out more to be in this case than in this case. So that is why these two are not equal, and similarly A intersection B union C is not equal to A intersection B union A union C. So these two are not equal, and then comes our next thing. So next big thing is distributive law. So A union B intersection C can be seen as A union B intersection A union C, and similarly A intersection B union C is equal to A intersection B union A intersection C. So it can be distributed among the both. Now there is one more thing, and this thing I am writing in separate color because this is important. A minus B intersection C is equal to A minus B union A minus C. So negative multiplied to intersection becomes union, and in similar way A minus B union C becomes A minus B intersection B minus C. So this is the thing, and now then comes to be, these were the distributive laws, and then comes to be De Morgan law. So De Morgan law is most important. A union B का whole complement is equal to A complement intersection B complement, and then it comes A intersection B का whole complement is equal to A complement union B complement. So complement also behave like negative. So yes, in this case this comes out to be like that. Now let us see the same thing in I don't know if this will become a triangle or not. So no, that became a O. So yeah, let us go and import some shapes, and then let us go like this. Yeah. So let us take two sets, A sets and B, A set and B set. So this one is A, this one is B. Now A union B is the region marked with green. So everything in A and everything in B, and everything complement of this is the region marked with blue. Everything leaving the green part. So yeah. So this is the whole part. Yes. Now I think I will have to make it again. Okay. Let this go. So yeah. I don't know why I don't like this, but yep, I don't like this. So A complement intersection B complement. This is B. So A complement everything leaving A and B complement everything leaving B have common this part only, because leaving this is nothing but common part of leaving A and common part of leaving B. So that is nothing but common part of leaving both. So we left both and then took the common part. So yeah, it's the same thing. In the same way, A intersection B, the complement, this part will also come to be here, and that will you can do it yourself. So yeah, I am not elaborating much because I am doing this for myself, not for you. So yeah, after this, uh, rules for the cardinality of different set. Principle of inclusion and exclusion, it is said. So principle of inclusion and exclusion is something very useful for very difficult problem, and this will be very useful in chapter permutation and combination also. So number of elements in A union B is equal to number of elements in A plus number of elements in B, because number of elements is nothing but a number, so we can add and subtract that. We can also add and subtract sets, but that is a bit different. Minus n of A intersection B, because when we will add this and this, we will get some common part that will be added 2 times, so we will subtract it 1 time. So this is one thing. Then if it is n of A union B union C, this will come out to be n of A plus of n of B plus of n of C minus of n of A union B. So let me write it properly. I should use some different color code here. Minus of n of A union B plus n of A union n of A union C plus of n of B union C. Let me move it a bit like this, and finally plus of n of A intersection B intersection C. I have written something wrong here. this is a thing. So yes, this is a formula. So this continues like this, and the generalized result here is n of a1 plus a2 plus let me use another symbol here, not plus, we will use union. N of A union B union C union, again I am wrong here, N of A1 union A2 union A3 union A4 dot 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 dot, N of union A n will come out to be S1 minus S2 plus S3 minus S4 plus S5 till S plus of S ka power minus S ka power, sorry, minus 1 ka power n into S of n. So alternatively it will go plus minus and plus minus. So this come out to be like this. So this is called principle of inclusion and exclusion, and there was a very good question given on the basis of this principle. So firstly, yes, so the question was, there is a square of dimension 9 into 9 units, and in how many ways can it be painted, in how many ways this can be painted if we can use two colors, red and blue, to paint it, and let me use another color, and constraint is here, no square of dimension 2 into 2 should be of same color. So basically we have to here ignore the fact that we can even paint half of the square as red or half of the square as blue, but yes, so a square will be like this. So I want to use some other color, like let's go with pink, and let's go with draw, and now shapes, squares, let's go. Now this square can be divided into, this is sorry. The initial dimension was 3 into 3 units. It was not 9 into 9. Sorry. 3 into 3 units. Yes. So this is 1. Oh. So let us say so these are all squares of dimension 1 by 1. So we can paint this square in two ways, 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 two ways, two ways, two ways, two ways. So a total number of ways in which it can be painted is 2 to the power 9, which is nothing but 512. And now the possibility that a 2 by 2 square is painted red or blue is only when this whole square of same color was not there, was painted red. So this square will be painted red, or this square will be painted red, or this square will be painted red, or this square will be painted red. So now let us use principle of inclusion and exclusion to do it. So here S1 will come out to be total number of ways, so it will be 512. S2 will be each set, so the number of ways in which this can be painted. Let us solve this. I am right now running out of time, so let us solve this question after few days. So thank you for watching my stream. Let us end.